Hello, sixth graders. It's time for our Unit 2 review. You have a test tomorrow, and the things that will be on the test are, can you find the factors of a number? Can you find the greatest common factor between 2 or 3 numbers? Can you list the first 3 multiples of a number? Can you find the least common multiple of 2 or 3 numbers? Can you tell me what numbers I can divide big numbers by using the rules for divisibility? And can you determine which math property is being used between commutative, associative, or distributive properties? So let's go ahead and get started and do some of the types of problems that will be on your test. The first directions will ask you to find factors of a number. That means we want to list out all of the numbers that multiply to be that number. I always start with 1, say 1 times whatever the number is. So 1 times 24. Then, now I can use those divisibility rules I know. I know all numbers that end with an even number are divisible by 2. So I know 2 will work. 2 times what? 2 times 12. This is a great time to use your multiplication table. If you're struggling, you can just go down the 2's list and see if 24 is on there. You know it will work. Go down the 3's list. 3 times 8 works to be 24. 4 times 6 works to be 24. 5 doesn't work. And then when we get back over here to 6, we know we're done. You can leave it as a list like this, or you can write it in a longer list like this. All I'm doing right now is going from here around to here. Let's go ahead and do 62. 1 times 62. I know 2 will work because it ends with an even number. 2 times 31. Now I can find out if 3 works by saying 6 plus 2 does that equals 8. If this number is a multiple of 3, it will work for 3. If it's not a multiple of 3, it's not going to work for 3. So that's how our divisibility rules can help us in the first unit on the test. 3 doesn't work. 4, these two numbers would have to be able to divide by 4. That gets a little trickier. This doesn't work because I know 60 is a multiple of 4, and the next one would be 64. There's different ways that you can think about that, but you can always go down your 4's list and see if you can find 60. If you don't find it, then you know it doesn't work. 62. And it didn't work. 5 doesn't work because it doesn't end with a 0 or a 5. 6 doesn't work because 6 has to work for both 2 and 3. 7 is one that I would go down my multiples list, and it doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. Doesn't end with a 0. When I get to about the halfway mark, I know I'm done. But I think we can safely say we're done right now. So we're going to say 1, 2, 31, and 62 are my factors. Finding the greatest common factor I can do in many different ways. I don't want you to think about every single way to do this. It's going to get too confusing. I hope that you have one way that really works for you. Unfortunately, I need to pick a way to show it to you. So I'm going to go ahead and I'm going to list the factors of each number, just like I did on the first one. And I'm going to find the number that's the biggest in that list. So I'm doing these as 2 separate problems here. I'm finding the greatest common factor of 32 and 70. So I'm going to do the same thing I did in the first learning target. I'm going to say 1 times 32, 2 times 16, 3 doesn't work, 4 times 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, and now I'm back to 8. 70, 1 times 70. 2 times 35. 3 doesn't work. 4 doesn't work. 5 times 14. 6 doesn't work, and 7 times 10. 8 doesn't work, 9 doesn't work. Now I'm going to look in this list. I see that I have in common, I have just my 2 and my 1. So which one out of 2 and 1 is the greatest? 2. The greatest common factor of 32 and 70 is just 2. The next one, I'm going to take 12 and say, all right, 1 times 12, 2 times 6, 3 times 4, 18, 1 times 18, 2 times 9, 3 times 6, 4 and 5 don't work, 30, 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, and then 5 times 6. So I'm looking through my list. I like to start at the biggest number here and say, does 12 work for the other ones? No, I don't see it in the other lists. Does 6 work? See how I'm starting at the biggest number from my smallest list? So I'm looking at 6 now. 6 works and 6 works. Now nothing bigger than 6 could possibly work because it would have to be 12 because it has to be in all 3 lists. So we know that 6 is my greatest common factor between those 3 numbers. Listing multiples, I can just use my multiplication table. That is the one and only thing you can use on your math test tomorrow. So I can just look at my 16s row and say, okay, 16, then 32, that's times 2, right? Then times 3, 48, and times 4, 64. My 7s, 7, 14, 21, 28. If I want to find the least common multiple, I can do the exact same thing. I can list my multiples of 8. We'll go up here, 8, 16, 24, 32, 40, 48. I can list my multiples of 14, 14, 28, and I'm trying to find one that they have in common. 42, 56, 70. I'm going to keep going on the top because I noticed 28 didn't work, 42 didn't work, and then I'm at this spot where I know I have to keep going. So I see 56 is actually in both lists. 56 is my least common multiple. Now, with multiples, that could go really far. And so I think it's nice to use another trick. I'm going to do the ladder method, or like the upside down stairs method. I'm going to divide something out of all 3 of these. So I can divide I was going to say a 2. I can't divide a 2. I can't divide a 4. I can't divide anything actually out of all 3. Now with least common multiple, it's different when you're doing the stairs than greatest common factor. On least common multiple, you can take something out of just 2 of the numbers. So right away, I see that these are both multiples of 5. So I'm going to take a 5 out. A 5 does not come out of 4. So 4 just stays the same. But I can take the 5 out of 15, which gives me 3. And I can take the 5 out of 30, which gives me 6. Now I can keep going if there's still a common factor between these. So I noticed that I still have an even number here and here, which means I could take a 2 out. Divide by 2, I get 2. I can't divide by 2 here, so I'm going to leave it. And divide by 2, I get 3. I see another one. Do you see it? I see 3. They both are multiples of 3 because they're both 3. So I'm going to divide by 3. I can't divide 2 by 3, so it stays at 2. 3 divided by 3 is 1. 3 divided by 3 is 1. So now there's nothing more that I can take out. Yes, I could take out a 1, but 1 never gets us anywhere, so we never use 1. So I'm going to go ahead and I'm going to make, this is why I like using this method for least common multiple, because I make an L with all of the side and the bottom numbers, and I multiply all of those together. So I have 5 times 2, which is 10. 10 times 3, which is 30. 30 times 2 is 60. 60 times 1 is 60, and 60 times 1 is 60. So my least common multiple between these 3 numbers is 60. All right, here we get to use those divisibility rules again. I'm going to go through each one as we check boxes. So what I'm looking for is a check to be in a box if the number can divide it. So I can try 390 divided by 1, 390 divided by 2, 390 divided by 3, and so on. I could actually sit and do a division problem for each and every one of those. And that is one way I could find out if you can divide evenly that number. But we learned some tricks in class to know if a number can divide another number really quick and simple. So 1 works for every single number. We learned that. So we're going to make a mark in the ones every number works. Going through the 2s, 2, the last digit has to be an even number. So it has to end with a 0, a 2, a 4, a 6, or an 8. If it does, it's divisible by 2. So 0 works, 1 does not work. 0, again, works. Okay, so we're going to leave it blank if it doesn't work. That makes it a lot easier for me when I'm looking at your paper. A lot of kids will do like a check and an X, and it's kind of hard to know which one is which. So just don't mark it if it doesn't work. 3, the rule for 3 seems tricky, but once you get it down, it's pretty easy. You add up all the digits and you find out what the answer is. When the answer to when you add is a sum. So it says the sum of the digits. What I mean by the sum of the digits is I mean take 3, 9, and 0, add them together. What's the answer? So 3 plus 9 plus 0, I get 12. That is the sum of the digits. Now, if the sum of the digits, 12, can be divided by 3, it works for 3. It's a cool little trick. If the sum of the digits can't be divided by 3, it doesn't work for 3. So let's go and try it with the next one. 2 plus 9 plus 8 plus 1 equals 20. And I'm keeping these sums of the digits over here so I can use it again for my 9s rule, because there's a rule there that works for the sum of the digits as well. So 20 does not divide by 3. 20 doesn't work. If I add this one, 4 plus 5 plus 0 plus 0, I get 9. 9 does divide by 3, so the whole thing will divide by 3. All right, the 5s rule is very easy. You probably already knew it. If it ends with a 0 or a 5, it works for 5. So this ends with a 0, does not end with a 0 or a 5, and this one ends with a 0. Moving on to 6. 6, we talked about in class how 6 is made up of a 2 and a 3. And since 6 is made up of 2 and 3, if it worked for 2 and it worked for 3, it will automatically also work for 6. If it doesn't work for one of them or both of them, it's also not going to work for 6. So I'm basically looking at my work of what I've already done, and I'm saying, look, this one worked for 2 and 3, so it's going to work for 6. There it did this thing again where I'm losing transparency. Hopefully you can see it well enough. Okay, and then the next one, clearly there is nothing here for 2 and 3, so there should be nothing here for 6. And then on the next one here, I've got 2 and 3 both, so again, it works for 6. I know what I did. Here we go. Now you can see it. All right. Moving on to number 9. So this one, was if it worked for 2 and 3, it works for 6, but it has to work for both. 9 is the same thing. The sum of the digits has to be divisible by 9. So here for 3, it had to be divisible by 3. For 9, it has to be divisible by 9, which means if it worked for 3, it won't necessarily work for 9. We have to check. So if 390 added up to 12, 12 cannot be divided by 9, so it does not work. The sum of the digits on this one, 2,981, was 20. That does not work for 9. And the last one, 4,500, the sum of the digits is 9. 9 can divide by 9, so that one works. And the last rule, if it's divisible by 10, it ends with a 0. This ends with a 0, and this ends with a 0. Make sure to check over those divisibility tricks and rules. Those are things I'd like you to memorize that will help you in your future. Last learning target. This is the properties. Oops, and it looks like it moved here on me, so hopefully you can kind of see what I meant to do. This distributive property should be over here. This one should also be over here. You are just choosing the correct property. So, oh my, lots of things did not transfer on here. So, this should say, actually, just ignore this little box that I don't know how it got there. But as long as that box is gone, it should say 2 plus the quantity of 5 plus 9. When I say the quantity, I just mean it's in parentheses. And then the quantity of 2 plus 5 plus 9. I notice that it says 2 plus 5 plus 9, 2 plus 5 plus 9. The order is the same. I also notice that the math problem's the same. 2 plus 5 plus 9, 2 plus 5 plus 9. The thing that's different is that the parentheses on the one is grouping the 5 and the 9, and on the other it's grouping the 2 and the 5. It's telling you to do something different first. And we're saying that doesn't really matter when all you're doing is adding everything. That's the associative property. The associative property is saying that you can move the parentheses if all you have is plus or times. Moving on. The next property I see, again, ignore these boxes, is taking this 8 and multiplying it by the 7 plus 6 in 2 chunks. So we're taking the 8 times the 7 and the 8 times the 6. So I see 8 times 7 and 8 times 6 and adding those together. That, when I do this and I transfer it across the parentheses, is the distributive property. Think of it as I'm distributing the 8 across the parentheses. So here we go from having one set of parentheses to 2 sets of parentheses. The parentheses didn't really move, it changed the problem, right? We see the 8 twice now, where before we just saw it once. So we're taking the 8 and we're distributing it to the different numbers. And the last property that's shown here is the commutative property. I know it's the commutative property, not just because it's the only one I have encircled, but because I'm noticing that the order of the numbers has changed. So the commutative property says the order that you add things or the order that you multiply things in doesn't matter as long as that's all you're doing. In this problem, 2 plus 7 plus 8, I changed the order to be 2 plus 8 plus 7. I might do that because if I'm trying to do this problem in my head, making a grouping of 10 makes it easier, right? So I know this side is 17. If I take this side and say 2 plus 7 plus 8, it's a little bit trickier for my brain. So it's saying it's okay if you want to switch those numbers around. The order doesn't matter. That's the commutative property. There is a very good resource for you. It's called IXL. A lot of students got to try IXL last year and maybe didn't love it. However, there are some really good benefits to IXL that I'd like you to try if you're still stumped on any of these learning targets. So if you go onto Google Classroom, you will see a link for IXL. Right above the link for IXL, it will tell you what your username is and your password. So everyone's password is SJS. You need to look and say, okay, what is my username based on the information I gave you? It should be the first initial of your first name and then your full last name. Unless you have someone else in the school that matches your information, then you're going to need to add a 1 or maybe even a 2 to the end of your name. We've gone in there before, so students should be able to access it. When you get in there, you're going to see a little thing that has a star, and I think it says 6 skills suggested by your teacher. Those 6 skills are skills that I'm testing you on. You don't need to do them all. Try the skills that you're having the most trouble with. It will give you practice problems and you can test yourself. How am I doing on these? If you're not doing so well or you're not feeling very confident, there is a button that says video. Normally it's up in the right-hand corner of every question, and it will show you a really good video on how to do those types of problems. They're very thorough. Each video is somewhere between 3 and 10 minutes long, and you can watch them on any of the skills that you need. Good luck, and I hope you all do super well on your test.